Hello students, in this video lecture also I'll be continuing with the 8085 microprocessor instruction set, that is arithmetic group of instructions. Here I'll be discussing. In the previous lecture also I discussed about the arithmetic group instructions, and now some more arithmetic group instructions that I'll be discussing in this lecture. So to start with, the next arithmetic group instruction is ADCM. So I have told you in my previous lecture also, when I will be using wherever in whichever instruction, if I am using M, so M here means that memory location whose address is pointed by or given by HL pair. So suppose the content of H is 20 and the content of L is 30H. So the memory location is 2030. The address of the memory location is 2030H and it is represented by capital M. So here ADCM represents addition of the content of accumulator with the content of memory location whose address is pointed out by HL pair and carry flag. That is, if the accumulator content is 20H, if the content of memory location, suppose this is 2030H, if the accumulator content is 20H and if the HL pair content is 2030H, and if the content of 2030H memory location is 40H, and if the carry flag is in set condition, then what will happen after the execution of this instruction? The content of accumulator will get added to the content of carry flag and the content of the memory location whose address is pointed out by HL pair. So here the HL pair is 2030H, so the memory location is 2030H and its content is 40H. So the after execution of this instruction, what will be the result? 20H plus 40H plus 1, it would be 61H, and it will get stored in the accumulator. So this was about ADCM. Obviously it is an arithmetic group instruction, so all flags will get affected. Then number of bytes, since ADCM, since this instruction does not have any hexadecimal number along with it, so the number of byte of this instruction will be 1. Then the machine cycles, how many machine cycles will it need? It will need 2 machine cycles. How 2 machine cycles? 1 machine cycle for fetching the opcode, that is, after fetching the opcode, microprocessor will get to know it has to add the content of accumulator with the content of the memory location whose address is pointed out by HL pair. So microprocessor is having the address, but it has to read the content of the address so that it can execute the whole instruction. So the second machine cycle will be used for reading that data from the memory location whose address is pointed out by HL pair. So in the 2 machine cycles, the whole instruction will get executed. First is opcode fetch machine cycle and the second one is memory read machine cycle. Number of T states, obviously opcode fetch machine cycle will require 4 T states and memory read machine cycle will require 3 T states. So all total 7 T states, 4 plus 3, 7 T states. Now addressing mode, ADCM, since here the operand, its address is indirectly specified by the HL pair, so the addressing mode of this type of instruction is registered indirect addressing mode. Now the next instruction is ACI 8-bit data. ACI 8-bit data. So what this instruction will do, it is again an arithmetic instruction. It will add the content of accumulator with the data, 8-bit data mentioned in the instruction, plus the carry flag. So if carry flag is in set condition, then 1 will get added. If carry flag is in reset condition, then 0 will get added. So whatever is the status of carry flag, that will get added to the accumulator as well as the 8-bit data. So flags affected, obviously all flags will get affected. number of bytes of the instruction. Since this instruction has one byte hexadecimal number mentioned in the instruction, so the number of bytes will be 2, one for opcode and one for the hexadecimal 8-bit hexadecimal number mentioned in the instruction. Machine cycles, again it will need two machine cycles. First machine cycle will be used for fetching the opcode. After fetching the opcode and decoding it, microprocessor will get to know that it has to add certain data to the content of accumulator and carry flag. So that data is present in the memory. So the second machine cycle will be used for reading that data from the memory, and the instruction will get executed. So two machine cycles, one for opcode fetch and the second for reading the content reading the data that is mentioned in the instruction from the memory. So all total T states, opcode fetch machine cycle will require 4 T states, memory read will require 3 T states, so all total 7 T states. And addressing mode, here the data, that is operand, is directly mentioned in the instruction, so the addressing mode of this type of instruction is immediate addressing mode. Now this was all about the arithmetic instructions. Till now I have discussed all the instructions in the arithmetic group which are related to the addition process. Now we'll deal with those instructions which are related to the subtraction process. So first is SUBR, same as ADDR. What SUBR will do? It will subtract the content of register from the content of accumulator. Suppose the accumulator content is 30H and the register, suppose I have mentioned SUBH, and suppose the content of H is 10H. So after execution of this instruction, what will happen? The content of H will get subtracted from the content of accumulator, and the result will get stored in the accumulator. That is 30 minus 10, it is equal to 20H, and this 20H hexadecimal number will get stored in the accumulator. Okay, flags affected, again all flags will get affected. All flags will get affected since it is an arithmetic operation. Number of bytes, as you can see, there is no hexadecimal number mentioned along with the instruction, so the number of bytes will be 1, which is the opcode. Then number of machine cycles for this instruction, obviously this instruction will need one machine cycle, that is for fetching the opcode, and after fetching the opcode and decoding it, microprocessor will get to know it has to subtract the content of the register from the accumulator content, and both the register and accumulator are present in the microprocessor, so microprocessor does not need any extra machine cycles for the execution of this instruction. So only one machine cycle, and that is for fetching the opcode, decoding and executing it. T states, obviously opcode fetch machine cycle will need 4 T states, so the total number of T states is 4 for this instruction. And addressing mode, obviously here the operand is the content of the register or the content of the accumulator, so the addressing mode is register addressing mode. Next instruction is SUBM. Again, what this instruction will do, it will subtract the content of memory location whose address is pointed out by HL pair from the content of accumulator, and the result will get stored in the accumulator. Suppose the accumulator's content at the time of execution is 20H, and the content of H is 40H, and the content of L is, we are supposing these things, L is, let it be 21H, and suppose this is the memory that is associated with the microprocessor, and the memory location 4021H is having the content 30H, or let us suppose it is having the content 10H. So what will happen? This is 4021H. So what will happen after the execution of this instruction, the content of memory location, this is the content of memory location whose address is pointed out by HL pair. So the address pointed out by HL pair is 4021. So 4021 is the memory location and its content is 10H. This 10H will get subtracted from the accumulator after the execution of this instruction, and the 20 minus 10 is equal to 10H, and the result 10H will get stored in the accumulator only. Now flags affected, obviously it is a arithmetic operation, so all flags will get affected, and number of bytes of the instruction, since this instruction does not have any hexadecimal number mentioned along with this instruction, so the number of bytes is 1. Machine cycle, obviously 2 machine cycles it will need, one for fetching the opcode. After fetching and decoding it, microprocessor will get to know it has to fetch the content of memory location so that it can subtract it from the accumulator. Microprocessor is having the address of that memory location because it is the content of HL pair. So the second machine cycle will be used for fetching the, or you can say for reading the content of the memory location, which is the which is pointed out by HL pair, and executing the instruction. So all total it will need 2 machine cycles, one for opcode fetch and the second for memory read. So T states, opcode fetch will require 4 T states, memory read will require 3 T states, so all total 7 T states. 7 T states is required for this instruction. And then addressing mode, obviously here what is happening, the content of the here the operand, that is operand is its address is indirectly mentioned in the instruction. Again I am repeating here, the operand's address is indirectly mentioned in the instruction or indirectly mentioned by the register pair. So the addressing mode of this type of instruction is registered indirect addressing mode. So I'm ending this class here. We'll continue with the same arithmetic group of 8085 microprocessor set in my next lecture also. Thank you.